Okay, this is the video I promised you that I would send where I'm going to go through every problem in our last Mock ACP number 4 review. Uh, so this might, sit back and by the time you finish this video, you will have seen an in-depth explanation of every problem, all 14 problems on the review. And I'll try to get right to it. Of course, you might probably be a good idea to rewind anything that you need to hear again in case I go too fast. But I am going to try to speed through this. Fiona on problem number 1. Fiona owns 80 DVDs. The number of action adventure DVDs A is less than twice the number of comedy DVDs. Look at this. 8 less than twice the number of comedy DVDs, which is C. So 2C is twice the comedy, and 8 less than that is 2C minus 8. And that is equal to A, which is the number of action adventure DVDs. So this is one of the equations. The other equation is Fiona owns 80 DVDs. Some of them are action and some are comedy. So altogether, action plus a comedy should be 80 DVDs. So where do you see this? This is choice D. So choice D, if you're following along, choice D is where you have both equations represented. Let's move on to number 2. Bob Bullock, Texas State Museum charges $450 for adults and $350 for youth to tour the exhibits. A group with 10 more youths than adults paid $155. Now, 10 more youths wide than adults means adults is A. So 10 more than that is A plus 10, and that's the number of youths. So that's one of your equations. The other equations is, it says which system of equations can be used to find the number of adults A and youth Y in a group. Well, you know one of the equations is A plus 10 equals the Y. I'm going to bold that just so make sure you see it. So you know that's one. And then the other equation, each adult pays $450 and each youth pays $350, meaning since they paid $155 together, $155 altogether, then you have this equation. This equation here says, if I bold this, means that each adult paid $4.50 and each youth paid, the youth price for youth was $350 and altogether is $155. So your two bolded equations are selection G, and that's what you should go with for your system. That's the correct system there. Okay, let's move on. 3. Told you I'd be moving. Which of the following systems of equations can be used to determine a point of intersection or lines whose coordinates are given in the table below? So here's the x values, and you got 2 sets of y values. So you pair line 1 with x, that's one line. Well, this is the x and y for one line, and then the x and y for line 2, there's the x and these are the y values. So you're going to get 2 equations out of this. You can get an equation for this group and an equation for this group. Well, all you got to do, I noticed that all the lines are different. So really, if I just find the equation of one of these lines, it's going to be part of one of these systems. And if I find the slope of line 1, which is use the slope formula, subtract the y's over the x's, you'll get a slope of 15. And because the y-intercept is where x is equal to 0, that gives me the y-intercept. So my equation of my line is 15x, y equals 15x plus 20. That's the equation for line 1. Well, you only see y equals 15x plus 20 in choice G. There is nowhere else. The only other slope of 15 you got is J. And it can't be J because J has no y-intercept. So the only choice G has a line with slope 15 and intercept 20. And so that's the slope equation form there. And that's why G is the answer. Look at 4. Which graph shows the solution following system of equations? probably the easiest thing to do right here is just to graph these using graph member menu 3313 and just match the system up. And that's exactly what we're going to do. So let's go to graph. This is another graph here. I'm just going to insert a problem here, doc 4, 1, and I'm going to just do another whole graph there. And we want to use menu 3313. We need that to put that in the proper form. So let's go back to the problem there. We need 2x plus 3y equals a -3. I need to move this out the way. All right, so that's 2x 3y that equals -3. I'm going to put a -3 there. Go ahead and make sure and check. Make sure I have the right. Yes. And then 4x, let's go down and put in 4. I already got the x here. 4x minus y. Since I have a plus, I have to make the y negative by putting a -1 in front of it. And let's put an h there, an 8 there. Press enter, and there's my line right there. There is my system graph. So maybe we want to make it even more like the graph. Let's go ahead and turn on our grid with menu 263. Menu 263. Now we can see it pretty good where it is. All right, it looks like x is between 1 and 2, and y is exactly -2. So if I want to use menu 64, just to make it obvious, I go ahead and put that there. But if I go back to the problem and I look at either one of these, it looks like the one that looks like B is the best choice because it's right at -2. Notice that the rest of these intersection is not at -2. Well, y is equal to -2, so B is the choice there. And just so you can see, it looks like that. Let me go back. Let's capture this because I like to be exact. I'll go ahead and just capture that. And let's go back to the problem here, and we'll paste it there. That's real big, okay? And so you can see if you put this right up next to, it looks almost exactly like B. So that's why B is your choice for this system. And go ahead and indicate that right there. So B is a choice for problem number 4. Let's look at problem number 5. Customer ordered several pounds of snacks for a party. Each pound of peanuts costs $4, and each pound of cashews costs $10. Let P be the number of pounds of peanuts. Well, that's something to say. And let C be the number of pounds of cashews. If the customer spent at least $100, at least, that's very important to highlight, at least 100. Which of the following graphs represents the inequality determined by these conditions? At least means greater than or equal to. So that's what at least means. So 4 pounds of peanuts looks like this, and 10, well, let's see, is that right? Yeah, a pound of peanuts is P, a pound of cashews is C. Each pound of peanut is 4, and each pound of cashews is 10. And so here's an expression for what he ordered, but it needs to be at least 100. So that means it's got to be greater than or equal to 100. We learned with inequalities that when you graph an inequality like this, it's going to be a solid line if it's less than or equal to. The equal to makes it a solid line, and the greater than means it's shaded above. So these look almost the same, except for only B is shaded above right here, and it's a solid line there. So that's the correct answer there. Okay? All right. Now, your graphing calculator can also do this, and I'll go ahead and show you. If you have the right operating system, you can do this. and ours happen to do so. So let me show you how you would actually graph this. You would go to, let's see, let's just doc 4, 4, and I'm going to kind of like, I'm going to delete that equal sign and press 6 for relation. And if I do that, okay, there you go. And I'm going to actually graph that same thing. I believe I had 4, and I need to use X for P, and I need to use 10. I need the Y for the cashews, and I need this to be control equals, and I want to be greater than or equal to 100. And if you press enter, you get the graph. And it's not at the right. We need to make sure that it kind of, that the scale is the same. And let's look at the problem again. And you see the scale here looks like that's up around 30. We need X to go, Y to go from 0 to 30. And it looks like it's going 0 to 30 both ways. So what happens if I do that here? What if I take this 10 and I make it a 30? And what if I take this Y max, make it 30? Now you can see what this thing is starting to look like. And if I want it to be pretty, I could go ahead and go, escape all this. I could also go menu 2, 6, 3. And then you can see here clearly, this is a solid line. I'm gonna make it obvious. Now you can see that that's a solid line and it is shaded above. So, and I'm going to graph, I'm actually going to import this in. And let's go back to the problem. And I am going to paste it. That's huge. That's huge. Now I'm making lines all over the place. Where are these lines? Okay. And if I could just make this smaller. And you make this smaller and you compare which one does this look like? Rid of some of these extra lines that I got going on here. Delete. All right. And let's get rid of that extra line. Not that. Let's get rid of that. All right. So that's what it looks like. So which one does it look like? Not that one. Looks exactly like that one. Now, notice that it's shaded above. So that's why the answer choice is B. All right. And that's why we're circulating B here. So that's the shape here. And that's why B is the answer choice there, because that's what it looks like on the calculator. All right. Okay. Not every calculator can do this. Only calculators that have OS operating system 4.3. And not all the calculators in the building have that OS. So you may not be able to do this on every calculator, but in the ones in my class, you should be able to do it on. Okay. All right. Look at 6. Let's move on. Which of the following inequalities represents the solution set? I am drawing lines crazy here. All right. Which of the following inequalities represents the solution set depicted? Okay. So here's the graph, and here are the 4 inequalities. Now I'm already thinking this thing is shaded below. So if it's shaded below and dotted, that means it's going to be a less than, which means I can pretty much rule out these. I can pretty much rule out this one, and I can rule out that one. So it's probably going to be either out of F and H. All right. If I go ahead and get the name of this line, because every line has a name, this line has a slope of 2/3. And you're probably saying, how did you know that? I'm going to draw the slope. I'm going to draw. Look at that y-intercept. So the y-intercept is 2. And if I go to the next intersection, I'm going to make a slope triangle that looks something like that. And so you can see here that it has a rise of 2. And it has a run of 3. And all these are positive. This is an uphill slope. So the slope is 2/3. And the y-intercept, which is this point right here, I'm going to put a line, I'm going to put a point right there if I can. Let's see, yeah, all right. I might be able to pull this off. If you look right there, oh, I drew another line. Let's try again. Let's see, and there, try it again. Right there, if you look right there, and I think I can pull that circle over. The y-intercept is right there at 2. So the line in slope-intercept form, that's y equals mx plus b form. So the line looks like that. Okay, so yeah, but none of these are in slope-intercept form. These are in standard form, which looks like this. I'll just go ahead and make an equation. This is called standard form. Yeah, yeah, I know that looks crazy. Standard form. Okay. So how do you get from slope-intercept form to standard form? Okay, I'm going to make this a lot smaller because these are all standard form. Okay, so how do I go from? So what you do is you just actually start off with the equation. All right, you want to get rid of the fraction. So multiply everything by 3 to get rid of that denominator. When you do that, you're going to have to use the distributive property on the right side. So you'll get 3 times y, that's easy on the left. But on the right, you're going to get the distributive property. The 3's cancel out, you're going to be left with the 2x. And 3 times 2 is 6. That's the distributive property. Now you're looking close. All you got to do to get it in standard form is subtract 2x from both sides. It disappears from the right and shows up on the left because you can't subtract 2x from 3y. So if I move this over, you'll see what I'm talking about. And you remember when we did that where we had drew that line? Let's see, I'll do this. We drew our line here. We made sure that our equal signs were lined up, and I really should have done this all the way up. And let me do that. And you'll see this again on some other problems later on in this review. And as you can see, we were actually just trying to we weren't really solving for anything other than to get x and y on the same side. So really, it's trying to get x over and I just saw another way I could have done this, but just trying to get x and y on the same side. When I do that, then I'm only going to end up with choice H because that 2x is going to become negative. So that's how we get standard form there, and that's how we make our choice there. Okay. Again, shaded below and dotted means less than. Okay. Let's go on to problem number 7. About half done. Which of the following represents the solution to the inequality y is greater than 3 minus 2x? Notice that all the lines are the same, so I wouldn't even bother graphing this. You already know it. You just got to decide which one of these looks right. But all the lines are the same. But because I have a less than, it's got to be dotted. So so that means this one, no go on that one, and no go on this one. And then since the line is greater than, it's got to be shaded above. So that means F is the only choice there. So I wouldn't waste any time. Now, I wouldn't waste any time graphing this unless you just want to just double check. And if you can, this is really easy to graph. All you have to do is just literally just open up a graph page, and you can erase the equal sign, choose, I believe it was less than, which one was it? I've already forgotten. All right. I want to keep it, yeah, y is greater than actually. So y is greater than, and this will work on any calculators, not just my calculator, but pretty much any calculator. Any Inspire will do this. And you can see it, there it is. Now, the problem is this looks like this is a solid line, but it's not. It's dotted. Okay, you just have to make sure it's not highlighted, and now you can see that it's dotted. So that way you can double check. If you want to double check your results, you can. And I'll go ahead and take this and copy it and paste this as well. All right, so if I do that and I paste it, all right, yep, okay, and as you can see, it looks just like that one, okay? All right, so now, now the rest of these are I'm going to actually take these a little faster because I've done a lot of the work in beforehand, and then I might see if I can capture some of these other videos separately. We'll see how it goes there. So with the solution of the system below, all right, all you got to do is just graph it. That's it. Just use graph menu 3 through 1, 2, 3, graph, and you will see that you get what looks like one line. And the reason why mine looks like this is because I used a little magic to make one of the lines dotted. But either way, you're just going to get one line. So the lines coincide. That means you have infinitely many solutions when that happens. Okay? Now, this is the one that people had the most trouble with. Okay? And I have a whole separate video on just this problem. Okay? So, but this is the short version. Jeremy has a collection of dimes and quarters. Overall, he has 51 coins, and our total value is 1035. What is the total value of only the quarters? Okay, only the quarters. Here's just like the dimes and quarters, dimes and nickels problem we had. Here's the system. D plus Q is 51. 51 coins altogether. Each dime is 10 cents. Each quarter is 25 cents, and you get $10.35 altogether. If you would just simply graph the system with menu 3313, that's what I use. Menu 3313, well, same one we use on other problems. Then use menu 64 to find intersection. You'll get this. And this tells me that since the intersection point is 16 and 35, 35 quarters. Well, how much is 35 quarters? 35 times 25 is $8.75. And then you just fill in your griddable like this. All right? Method number 2 is even more exact. You just go to algebra, menu, sorry, I didn't do it right. Go to the calculator, go to menu 32, fill it in just like this. Make sure you use D and Q, and they'll go and take the answer straight like this. Okay, I have a separate video on this if you want to see this again. Maybe see me actually do this. All right, so look at number 10. These are very simple, okay? All right, we had this problem way back in the beginning. This is one of the first problems we did. So we drew our line. We decided we want to get x by itself, so we put an x over where the x was. And then we moved everything away from that side until x was the only thing. So subtract, so you're going to say add 9 to both sides because you're subtracting. You got to use the inverse operations. And then you're going to divide by the coefficient of x on both sides, and that's how you get the answer 3. Real simple, okay? And of course, you can actually use LinSolve on this problem, but I'm not going to demonstrate it here. Same thing with this problem. We do exactly the same thing. The only problem with this problem is that none of these are correct choices. And as you can see, I picked the left side for A because they had all the A's on it. And you're going to always collect like terms. Collect like terms. Remember, that's what we use to help us remember. Collect like terms. That's what we did on this side. And on this side, we use the distributor property, dp. So we use that here. That's how we got that. We collected like terms first, then we use the distributor property. Then we use inverse operations to get all the A's on the A side, divide through, and that's how we got the correct answer of 10. So that's one way to do this. And of course, yes, you can do this in LinSolve too. Same thing with this one. Well, not the same thing. You can also use graph menu 3313 and menu 64 to find the intersection of the two graphs. Or you can use LinSolve. Either one of these is fine. I don't know if I have a separate video on this or not, but I think I do. If I do, I'll upload it later. Or you can also just use LinSolve, and it might actually work a little better here. So, all right, LinSolve works fine for problem number 12. And we get to the end of it. I have separate videos for this problem. Okay, but here's a short explanation for it. Okay, if you put this in the calculator and list and spreadsheet, okay, like the years column and the home runs column, and you do a linear regression, it will give you the equation that you will use to figure out to make the prediction. And I think you ought to watch that video, but this is mainly what you're going to use menu 413 and list and spreadsheet to do problem number 13. And the correct answer is H. I have a separate video on that. There's also a separate video on this problem as well, but here are the high points. Okay. Here I added to the convention of renaming the years 0, 1, 2, 3, 4, 5, 6, 7. Why did I do that? Do that because it makes the numbers a lot smaller, a lot easier, more exact when you make the X values or the dependent values, simpler numbers, because they're just years. So calculators know the difference. So we're going to put, there's a separate video where I put this into list and spreadsheet. I use menu 413 again, menu 413, and list and spreadsheets. List. I think it's list and spreadsheets. That looks messy. See if I can straighten this up. Yeah, that's better. Okay, that's enough. All right, list and spreadsheets. All right, you put that in there, you're going to get this. Once you do menu list for 413, it's going to tell you M is 727, and you round that and that's basically it. I mean, it's really just straight. So we've gone through all 14 problems. Again, if you want to see these other problems, the problems that I mentioned, 13 and 14, they have separate videos. Feel free to watch those if you want to see me go slower and actually see the button pushes. Other than that, have fun studying for the test, and I hope you guys do well. Bye-bye.